What's up, Z? I'm gonna give about 2 minutes, let people show up if they want to. Miss Abadea gave me a couple areas where she told me I should focus on with you guys, and that's what I was gonna do. And if you guys have any questions, we can go over those areas as well. Hey, Sebastian, and I don't know who Chan Wu is. Yeah, you. Alright. And Spaz. So the first one she told me to focus on with you guys is density. Alright. So, there we go. So there's different properties. There's physical and chemical. She wanted to make sure that you guys knew the formulas. So density is going to be mass over volume. Solubility is basically how quickly something's going to dissolve. Malleability, bending. Luster's shininess. Conductivity is basically electricity, how well it can do that. Boiling point is when it basically starts to turn into steam. Melting point is when it melts. I think you guys get that one pretty much. Those are all physical things that we can all basically detect with our senses. You know, we can see it, hear it, taste it. Whereas chemical properties is when it's going to combust, burn, or explode. Rust, getting, old or tarnished. They kind of go together, rust and tarnish. Acidity, here's your acidity base here. So 7 is always going to be your neutral. And then you can see as you go, there's the 1, you get strongly acidic, 14, strongly alkaline. So she wanted to make sure I did that one. We've got basically up here as well, element is the 1 type, compounds when you combine them. When they're a pure substance combined of more than one thing, when a mixture is obviously you mix them together. Did you guys have any questions about those, or I'm going to move on to the next one she has listed for me to go over with you guys. Miss Abadea will be coming on to also help explain things, hopefully. So, okay. The next one, well, I just can't spell, but it's right there. So, atomic theory. All the different guys. I'm going to admit this is hard for me sometimes even to keep them all together, so let's go through them. Alright, so first we've got Dalton. He's the one that basically says all atoms from an element are identical, can't be created, everything's made of atoms. This is where the idea that atoms is the basis of life. Then we go to Thomson. Atoms are positive spheres, negative electrons. This is where we start to get the, the plus, the minus, all that kind of stuff. Rutherford's going to be our nuclear model. Core, you got the nucleus with the protons there, and then electrons can go from one to the other. Chadwick, we've got the nucleus contains uncharged particles and neutrons. Now we have electrons, protons, and neutrons at Chadwick. And then we go to Bohr, and this is where the atoms' electrons move around the nucleus in different orbits, closer, further away, according to their energy. Planetary, like kind of like a planet, you know, circularly. Oh man, they started really early tonight. If it does get this way, guys, I'm probably just gonna stop it. So, anyways, so we've got our little reminder down here: protons, positive charge, positive. Electrons are going to be the negative. Neutrons got no charge. Ions, we have atom gains with negative and loses, or atom gains are negative, whereas when they lose this, they're positive electrons. An isotope atom gains or loses neutrons. Hey Steven, what's up, bud? So we got the periodic table. Just a little reminder here. You got your nonmetals, metals, metalloids going down. The next one she said. Oh. So. Let's see. What else did she want me to go over with you guys? Energy forms. Alright, so we got the different states of matter over here. So solid, obviously you guys know that, like I always think of a rock for that one. The molecules are very dense together. They basically they're really tight together. Think of that when we did like our populations. I used the word dense. There's a lot of people. Liquid, we're starting to get a little bit more where they're not as connected and they're going to move past one another and spread out. And then we have gas, where there's basically molecules bouncing everywhere. And then we have plasma. Really, plasma is going to come into play with like lava and stuff like that, where the molecules are moving super fast. Temperature, we've got Celsius and Kelvin. Celsius is the one that most they use. We use Kelvin because we like to be different. So water boils at 100, water freezes at 0. We've got heat. Let's do energy while we're here. So energy, ability to do work, double different types. Chemicals, energy in the food. So when you eat it, your body breaks it down and turns that. It metabolizes the food and makes it energy for makes it energy so that way we can do whatever we need to do. Nuclear, again, this is potential energy, means stored energy essentially. It's like it's waiting to be used. It's there. It's not doing anything at the moment until it's put into something else. There's nuclear energy in everything. Gravitational, basically, the force that's weighing us down. And then stored mechanical, this thing is ready to move. Kinetic energy is always going to be moving. So when we go around the room, you're being kinetic. You're in motion. Will we get the formula to calculate like force and velocity and stuff? Hopefully Miss Abadea gets on. In the past, I want to say they have, Justin. I'm not 100% though off the top of my head. So. Sorry, bud. Friction, you do that every time you take a step. Basically, it's when the two things rubbing against each other that's causing you to lose energy. So the reason that when you roll a ball into the grass it slows down is that the grass is constantly taking away a little bit of its energy, a little bit of its force, and it's transferring into the grass, and therefore the ball eventually is going to slow down and stop. So, law of conservation of energy cannot be created nor destroyed, only transformed. So basically it can only change from one force to another, because matter is matter. Then you got a couple different types there. Alright, so let's go over speed, velocity, acceleration, since you're bringing it up over there. So speed is, you're changing your distance over time. So you can calculate it by how far you've traveled and the amount of time it's taken you to travel that distance. Velocity is how fast, essentially, you did it. Acceleration is basically the change in velocity. So as you get faster and faster and faster. Yeah. Anyways. Your force is your push or pull on any object. That's going to be your newtons again. And then we've got the three laws of Newton. So objects that stay at rest are going to stay at rest unless they get pushed or pulled by someone or something happens to them. Inertia. So the fact of the matter is, you know, once you start believing in ghosts and everything, if you have a can of soda, it shouldn't fall over just for nothing. Something has to knock it over. Newton's second law, greater the mass of an object, greater the force needed to accelerate it. So the bigger something is, really simple, the bigger something is, the more it's going to take to move it. So mass is the amount of matter, weight is the force of gravity acting on it. And the third law, for every action there's an equal and opposite reaction. So if you were to punch your can of soda and it fell over, when you say go over velocity, what do you mean, Zeno? But I'm going to finish up while I wait for her to respond. The reaction, the equal and opposite reaction, is that the can then falls over and the soda spills out. So velocity right there is going to be your speed with your direction. So velocity can be used to describe, like, when a pitcher throws a baseball, how hard they throw it. I threw the baseball in that with that speed in a particular direction. So they ask, what was the velocity on that fastball? So for me, coming from a baseball background, that was just how I always thought of it. Let's see. Work is the use of force, or joules. Power is how fast, talking watts. And then we've got all those simple machines. I know you guys started. Yeah, good job, Justin. Wedge, pulley, inclined plane, screw, wheel, and axle, and lever. I think they have them down. No, they don't. Well, I can pull those up if you need to, if you need a reminder of what those are. But that hopefully should have been like 6th grade right there. Let's see, what else did she have for 8th grade? She had the electromagnetic spectrum. I'm not gonna lie, this is not my strength right here. So I'll wait to see if she's here. Is motors and generator. Now I'm in the 8th grade one, just so you know, guys. I do have the study guides and cheat sheets for 6th and 7th grade ready to go. So right now, if you have a suggestion for one, make sure it's 8th grade, if that makes sense. I can go to the other ones in a second, but I just don't want to keep flipping between all of them. So is motors and generators going to be 8th grade, Sebastian? Oh, there it is right there, as I read it right there. So, electric motor is going to be converting electrical energy to mechanical energy. Generator is basically the backwards version. Mechanical energy into electrical energy. So a generator is what you do when the power goes out. You power up the generator with mechanical energy, and it's transforming, it turns your lights on. Whereas the electric motor, so you're taking electricity, think of that like the spark that it takes to start your car, because you only use your battery for one thing, that's just to start your car, and then it transforms into mechanical energy. This video does save, yes. So you're fine, say no. Conductors are the things that basically conduct it, so like this is going to be water, makes it really easy, or metals. Whereas insulators are things like rubber, wood, stuff like that, that's going to stop it. So that's why, like, whenever there's a lightning storm, you never go underneath an like a metal fence or anything like that, because you're not really doing anything. You want to get like under a tree. You want something that's not going to, not a tall tree either, but you want something that's not going to conduct the electricity. That looks like that's it for 8th grade. I can come back, so if you're like, Mr. Wood, you didn't go over this, that's fine. I want to make sure I kind of get over everything she asked me to. So, 6th grade. There we go. Alright. I'll tell you this too, I know there's pretty much always going to be like a watershed question or something like that. I will go back to concave and convex, Justin, because I'm with you. The mirror stuff I understand completely. I will do that after. Let's go through 6th grade, because she also really wanted me to do. She told me 6th grade. She gave me a couple here. All right. So non-renewable resources. These are going to be your fossil fuels. Basically, think of like coal and things like that. It takes a long, long, long time for these things to ever come back, if they do come back. So that's why they're called non-renewable, because we can't just put them back into the ground. I can't just make them reappear. Renewable resources are going to be things that we can keep on producing. Solar, there's always going to be the sun. Wind, we always have wind. Hydro, we can just reuse the water over and over and over to power up a turbine. So these are things that we can use over and over. So that's the difference between non-renewable and renewable. So let's see. Secondary resources. Electricity, gasoline, hydrogen. Use the storm move. That one's pretty simple. We depend on these things. What the atmosphere is made of. I don't think they're going to ask a ton of that. Solar energy, greenhouse effect. Alright, cloud formation. So this one's a good one to have. So basically the water cycle. Maybe Ved just feels super good about science. And I do have some also like trivia questions I can ask of you guys later if you want me to. So if you want some review without me just like I'm just trying to go over this stuff pretty quickly, I can quiz you guys. And then hopefully if I don't answer anything, Miss Abadea will be here. Alright. So cloud formation. Bodies of water absorb energy, causing the water to evaporate. So basically the water gets hot. Sun's on it, you're heating it, whatever. The water vapor rises. As it rises, it cools, and then as it's cooling, it condenses and forms into basically these tiny water droplets, which create us clouds. And then there's a whole bunch of different clouds, which I know you guys got to know. More water stuff. Here's all the different atmospheres. Yeah, they like to ask about this one too. Alright, so the very top is going to be the thermosphere. There's very little air pressure. This is where most of our satellites are. Then we get the mesosphere. This is where meteors burn up. So, then we've got our stratosphere. This is basically where our ozone is, the protective layer from ultraviolet rays. And then we've got troposphere. This is where all our weather clouds are. Humans give greenhouse gases. Alright, so different types of clouds, as I was saying. Cumulus, those are the cotton ball ones. Those are the nice fluffy clouds. Stratus are the flat blankets. Cirrus, as you can see, are thin or feathery. And then we've had the nimbus, which means that's our rain clouds. Ozone. The planets. So what do you guys do nowadays? What's your way of saying it now that you took off Pluto? Do you guys have like a little saying like, my very, like, excellent mother. It was like something like that when I was in school. Very hard time. So if I was trying to memorize this stuff, alright, so I'll come back to the planet stuff. If I was trying to remember this stuff, I would remember it as the T's surround it. So thermosphere and troposphere. And I would remember troposphere because that one was like the weather one. I remember that would be at the bottom, and I remember thermosphere is at the top. So now it comes down to 50-50 for me. This is how I would do it in my head. Between mesosphere and stratosphere. I've heard enough songs where like they talk about the stratosphere with planes and stuff, so I would know stratosphere is next. So troposphere is gonna, I would surround it, T and T. At least I know those two are at the top and bottom, and then I would just go like that. I work my way up. That's how I would do it. Troposphere to stratosphere. This is the hardest one for me to always remember when I was in school, is the mesosphere. So I would skip that one, and I would go to thermosphere because I know that's where space is essentially. I believe we have a weather one in here, Justin. I think exosphere is at like the very top up there. So what do you guys use? Exosphere? That's a Miss Abadea question. I got these. I found these cheat sheets from other teachers, and I was using them because I've used them in the past. And for the most part, this has a good chunk of the information that's gonna be there. Unfortunately, just I don't know off the top of my head, but I'm sorry. So, what the thing that separates this is basically a giant asteroid belt. A lot of people I see miss up Mars and Mercury. I would always just know Mercury's closest to the sun. That's going to be the hottest. When they've done practice tests or when I've seen students doing J labs, I see this one get mixed up with that one all the time. Earth is always third. That's another good checkpoint for me. So the first four I really don't feel super, are hard. Jupiter's the biggest, followed by Saturn. Now this one I can understand, Uranus and Neptune. For me, it was always Neptune was next to Pluto, but Pluto's not on the list anymore, so it kind of makes it harder. But I would get Jupiter and Saturn, and then I would just gotta kind of know the order here, Uranus and Neptune. I will find one with exosphere, Nisa. I'm sorry. I thought this had everything correctly on there, so I apologize. Difference between meteors and comets. Rocks that burn up in the atmosphere is going to be a meteor, whereas comets are just, we see them go by. They're the ones with the giant wispy tail. My very excellent mother just served us nachos. Nice. Nice. So from what I'm reading, Anissa, exosphere would be up here. Okay. So it'd be around it. So my strategy of doing with the T's would have messed me up here. But I always, I go from top to bottom still. Troposphere, stratosphere, I never had trouble remembering. As you get higher, it'd be harder for me. I would just know exosphere at the top. Troposphere to exosphere, and I would work my way from bottom to up, knowing stratus was second. Oh, I hated the moon stuff. Alright. So, when you have full moon, you can see it. It's super bright. New moon, basically it's blacked out. You don't see it at all. And on its way from new moon to full moon, it's waning. So as it's, when we go from new to full, it's waning. When it's full to new, it's closing, essentially. It's waxing. That's how I remember it. So we're opening it up. It's waning. And as we're closing, it's waxing. You guys should know the seasons. Oh, watersheds. Okay, they definitely will do something about the watersheds. Because we have a lot of them, especially with the Chesapeake Bay. So, watershed, land that flows across on its way to a stream, lake, or wetland. Whereas we have river systems made up of tributaries, which are small streams. They feed into these flat areas called floodplains where the water spills onto it. The Chesapeake Bay is called an estuary where fresh water from rivers flows out into the ocean. I would say there's gonna be one. Now I don't know if they're gonna make you label it, but I wouldn't be surprised like a drag and drop. Like, I'm just being honest with you guys. I would not be surprised about a drag and drop. Wax on, wax off. Well, wax on would mean that you're going, wax on is going to new. Anyways. That's it, what she has for 6th grade. Let me ask you guys some questions, and hopefully she'll be here so she can help me. Alright. Really big font. I'm going to pick random ones. Alright. Should be able to see that. Alright, type it in the box. Good, Justin. Scientific method. A part of the scientific method is going to be the hypothesis. I'm only going to do at most up to 8 o'clock, Anissa. I wasn't planning on going super long because this is not my area of expertise. But I just wanted to help you guys get some practice on this. Alright, let's see. Let's do this one. So tell me, for this question, what is the independent variable? Very good. The frequency of watering the plants. Good job. Good job. So on that one I was asking what it is. Alright, so what's the dependent variable? So this one is frequency of watering. What's the dependent? The amount of the frequency of watering, the amount of water, yes. Or how often in this case. And then, as somebody already said, the growth of the plant, it would be plant height. That's the dependent variable here. Let's see. What are the constants? Give me some of the constants from this. Whoops. So I've got soil, sunlight, the type of plant, the pot that the plant's in. Those are all good answers. Basically things that are not changing, constants. Alright, let's go to another one here. Alright, for the next one, I want you to tell me what are we measuring? And how would we measure it? So what are we measuring and how would we measure it? Alright, mass, good. So how would we measure mass? So the answer is mass. And I was looking for grams, like we're gonna measure it in grams, and balance. Very good. Alright, let's take a look at the next one. Do you guys need me to post the answers for these? I was just trying to go quicker by doing the questions. If you need me to type out the answers, I can. Just let me know. Alright, please do. Okay. I'll do it after I go over each one. So what's going to be the force of gravity on an object? Eighth grade has a science as well tomorrow. Weight, good job. So it's going to be weight, so how do we measure a weight? What do we measure it in? Yeah, I don't have joules. I have... Let me see. Since you guys seem to be struggling with this one, I'm just going to put it over there. Oops. I'm gonna put the next question up there so it doesn't... I have newtons. I have newtons for me. So I'm gonna put the next one up there so that I can keep going here. So the amount of space an object takes up. Yeah, I'm just gonna keep doing them. That way you guys can work on it. And you guys can just answer with the letter that you see right next to it. So that way I know which one you're answering. Alright, so the amount of space an object takes up is... It's going to be volume. Good. Good. Volume. And you would measure it with a graduated cylinder. Alright, distance between 2 points. What's the correct term for that one? Length, good job. And you would measure length. Please get this one right. Length, how do we measure length? Use them all the time. Alright, kinetic energy. E. Man, it sure was a little warm today. If only there was a term for that. Good. Temperature. So how would we measure temperature? Hotness is not a scientific term. It's going to be Kelvin or Celsius. Alright, and the amount of matter contained in a given volume. What's that going to be? This is going to be about the molecules, but you can't just say molecules. It's about how much space is between each one of them. There's an official word for it. No, this isn't going to be mass. Mass is dealing with weight, or how much matter it takes up. So I get it, it's contained in a given volume. I get why you would say that one. It's not going for mass, at least what I got on my answer sheet. Alright, so what I got was density. And again, a graduated cylinder. Like how tight the molecules are together, how much space is between each one of them. So, I mean, the answer made sense to me, but I understand why a lot of you said mass. Like, that makes sense too. Alright, this will be good for you guys to practice because there will be one question I can almost guarantee every time. So A, let's make that kg, hg, g, dg, cg, mg. I missed one. DAG? I don't think that's the right one, but whatever. Alright, so how many kilograms would it be? Yeah, it's all grams. I get that. So, what would this one be? So how many kilograms would 3.2 grams translate to? There's different amounts of zeros. It is 0.0032 kg. This one's gonna be 0.032, and we just keep going down from there, guys. 0.32 grams is, I mean, it's literally telling you the answer right there. It's gonna be 3.2. And now we add the zeros on at the end. Oh, I messed up. That should be that. There we go. Almost messed up big time. So basically, it just is a matter of taking away a zero and adding it on to the end. Alright, good. So it seems like a lot of this is clicking for you guys, remembering it. Let's go to another one here. Alright. These will be quicker. Alright, what's the answer? Matter. Good job. Alright. See if I can mix it up here. Try that one. It is not compound, it's mixture. It's going to be mixture, guys. The difference, if it was chemically put together, it'd be compound. If it's physically, alright, here's the key word here to focus on. If it's physically, then it's mixture. What's another good one? Do this one. Plasma. Good job. Good job. Alright. Try that one. On to the scientists' ones. And it was plasma. Man, look at Justin with the quick answers. Nice. Nice. Alright, let's try this one. Another scientist. This is the one about, do you open the box or do you not open the box to find out if there's a dead cat inside. Nobody's got, not Bohr, not Rutherford. Schrodinger. Correct. Schrodinger. Schrodinger's cat. You guys never heard of that? Let's try this one. Another scientist. Dalton is correct. Very nice. Alright, I think you guys are getting the scientists. Alright, periodic table question. Very good, metalloids. The staircase ones are metalloids. Very good. Reaction that absorbs energy is called? Not chemical. Extermination would be killing them, or killing something. Endothermic. So this one I'm going to write out just in case. Endothermic. I remember this one just because I always remember taking it like endothermic. Like I'm taking it in, I'm absorbing the energy, I'm taking it in. Whereas the opposite, where you release the energy, is exothermic, like it's exiting. So, endothermic, taking in the energy, absorbing it. Exothermic, releasing it. Alright. Ooh, I like this one. Let's see if it'll actually copy and paste it correctly. Nope. Can't do that one. Potential, kinetic, I think you guys got. Okay, let's do this one. What type of energy is this? What type of energy is that? Yeah, science is hard. So what type of energy is that one? It's not renewable. It's mechanical. Very good. Sorry, my thing like froze. I couldn't see what you guys were typing. My bad. So, mechanical. Very good. So this one's mechanical. Let's try. Let's try this one. Fire or visible light? I'm going to be honest, guys. I probably would not have gotten this one. radiant. Man, you guys were quick on that. Dang. Nice. It is radiant. Let's see. Trying to find ones I think that are a little bit hard here. What type of heat transfer is this? What type of heat transfer is that? It is not conduction, it is convection. Convection, very good. Conduction is going to be like if you literally put your hand on the stove and burn it. Type this one out. I don't need to do this. How are sound waves produced? Like, so how do we make sound waves? Just while I find the next one. How do we make sound waves? Vibration, very good, very good. Alright, let's try this one. So fill in the blanks. What would go in A and B? So, very good. It's going to be pitch for A. I have not seen the second one. I haven't seen B yet. A is pitch. I don't know where Miss A is. She told me she was getting on. Alright, so the second word is intensity. Amplitude determines how intense it is. Alright. Let's see. Some more. I don't want to do wavelengths anymore. Let's get down to that. Convex, that stuff you wanted, the reflection, all that stuff. Okay. So, let's try this. Tell me what this one is. The bending of light as it passes through an object in space is called what? Guys, just leave it alone. Let me help you out, Steven. Refraction. Good job. Very good job. Thought that one was actually pretty tough. Type of mirror produces a smaller upright image. This is the tricky one. This is where most of y'all doing a coin flip. Let's see who's going to be right. So far, everybody's going convex. Terran's going different with concave. And the correct answer is concave. Concave. So concave is when it's upright, whereas convex is when it's inverted. So that's the difference. Convex inverted, and it's bigger. Concave is smaller, but upright. I know most of y'all probably had it down to a coin flip. It can be tough. Let's see what else. Alright, I think that's good for 8th grade. Did you guys want me to do some 6th grade review with you guys? Do it really quick, and then I was going to get off, like I said, at like 8. Honestly, I would double check to see if you guys can go back. My thing would be do all the questions you think you know for sure, and then go back and do the ones you're not sure on, instead of being stuck. And if you know like you're not good at something, do the same strategy you did for civics, where you go in and you write it down as soon as you get your scratch paper. Yeah, I can't do everything because I'm not staying up all night. Sorry, guys. Alright, let's see. Let's do... We did non-renewable, renewable. I think you guys understand that one. Alright, this one's just good to know. So what's the freezing point in water, but with all the different temperature scales? The kingdom like class to me. I think that's 7th grade, Anissa. I don't have that up in front of me. But yes, you do need to know that. Let me look really quick. So, the correct answers are 0 Celsius, 273 Kelvin, 32 Fahrenheit. So you wanted to see the parts really quick. There. Did King Philip come over for good spaghetti? There's your domain. Kingdom, phylum, class, order, family, genus, and species. This is 8th grade. And then another one. Let's see if I can get to it real quick. There's the water cycle. Where is the parasites they're going to ask about? There's no one. There's usually one question about the different types of areas you can live in, such as tundra, boreal forest, desert, tropical rainforest, and things like that. Yes, Tanish. What was that? Though we're almost at the end. Um, so I found this. So if you guys want to go to it, it's an open page. I think we're actually going to stop here because I got to go. That's just weird. Alright, so here. There's a link. You guys can click on it. And what I did was, in case you're wondering, the fact sheets are these things. The things that have all the information on it for each grade. And then the study guides is the questions I was quizzing you guys with that you'll see when you get to that section. Alright, so use those. Go ahead and study. I know I didn't go over everything, guys, but I gave you an hour. Do whatever you can, study, get a good night's sleep. I wouldn't stay up much later past 9 o'clock. And I'll ask her where she was. She told me. I will try to do math on Saturday. Okay, guys? I can't do it Sunday. Or if I do it Sunday, we have to do it early. So if you guys want to compromise, think of an early Sunday time. Like I'm talking lunchtime Sunday time. I cannot do it at night. That's pizza time? That's not even my right address. Alright. So we can talk about it in class about the next time we do it. Alright? Anybody got any? I know she never came in here, Steven. It's been established. Alright. Good luck. Y'all have a good night, okay?